Today's learning objectives include understand how to specify and deploy cloud-connected sensors and metering to move beyond traditional calendar-based maintenance and enable condition-based strategies. Learn best practices for enhancing cybersecurity and system reliability through real-life examples from critical infrastructure environments. And finally, discover how connected maintenance solutions can extend asset lifespan and reduce long-term operational costs while supporting smarter data-driven decision-making. We have two presenters today, India Gibson and William Brown. India Gibson is the U.S. Services Offer launch leader for Schneider Electric. She's responsible for the strategic deployment of digital service capabilities across industrial segments, including maintenance, automation, and consulting. Over her 8 years in the industry, India has led the launch of global service offers such as EcoCare, EcoConsult, EcoFit, and industrial automation. She's a recognized leader in service transformation and change management, frequently collaborating across teams to simplify complex service models and drive measurable customer outcomes. Also, we have William A. Brown, the Chief Engineer for Schneider Electric's U.S. Consulting Services team. He is responsible for technical governance and thought leadership for an engineering team of 150 plus electrical engineers focused upon power system studies, automation and control, design services, and consulting. Bill has authored numerous technical papers, is a frequently requested lecturer and trainer on power system engineering topics, and participates in industry standards activities with organizations such as NFPA and IEEE. And with that, I'm going to pass it right over to India and Bill to get started. Thank you.
Thanks, Dan. Welcome, everyone. I am thrilled to announce our webinar on Beyond Calendar-Based Maintenance, Best Practice for Specifying or Deploying Cloud-Connected Sensors and Metering. So as you all know, as facilities face increasing pressure to deliver greater reliability, tighter cybersecurity, and improved cost efficiency, traditional time-based maintenance strategies may not be enough. And today, we'll explore how those connected technologies like cloud-based sensors and metering are transforming maintenance from reactive to predictive, helping teams make smarter, data-driven decisions. So in our 45 minutes, our experts, as mentioned, will share our examples from critical infrastructure environments, highlighting how solutions are helping operations extend asset lifespan, reduce those long-term costs, and strengthen your system's resilience. So let's dive in and explore how we can move beyond the calendar and into a more intelligent, connected future for facilities management. So on our agenda today, we'll dive into, again, our real-world challenges that you all may be facing. We'll also explore why calendar or time-based maintenance is no longer enough. Next, we'll take a closer look at NFPA 70B and how continuous monitoring and condition-based maintenance are becoming the new standard. And this is where, again, cloud-connected sensors or metering will come into play and where the transformation really begins. And from there, we'll go beyond compliance and explore EcoCare. And that's Schneider Electric's connected service offer. You'll hear how it's helping our critical operations improve reliability, reduce cost, and make smarter decisions with real-time data. And finally, we'll have a Q&A session. So please feel free to drop your questions in the chat as we go. And with that, I am very happy to hand it over to our expert, Bill, who will guide us through the technical insights and examples. And I'll be back at the end again to close with the solutions that are available today to help you take the next step. Bill, over to you.
All right. So to kind of set the stage for what we're going to be talking about today, let's first talk about some of the challenges that are being faced today by those responsible for the maintenance of electrical systems. So the first is safety. Keeping the electrical worker safe is obviously paramount. The second is resiliency, keeping the lights on, and it allows downtime costs due to electrical issues to be minimized. The third is efficiency. Planning maintenance can be a very time-consuming task, and making the best use of the data available to us on equipment conditions can mean sifting through mountains of data unless you have an efficient way to organize and evaluate all of that data. And the fourth is sustainability, maximizing the potential of aging infrastructure. So a representative survey of over 400 customer sites revealed that 98% of those sites had electrical safety risks, that 89% didn't follow the maintenance recommendations of the manufacturer, that 71 lacked the spare parts to ensure business continuity, and 98% had no single line diagram or only a partial single line diagram. And all of those things are essential to being able to deploy maintenance safely and efficiently. So the first thing about preventative maintenance is planning. And why should I make a preventative maintenance plan? Well, it's more than just a good idea. It's required by NFPA 70E, the standard for electrical equipment maintenance. It also helps you to improve reliability, enhance safety, increase the lifespan of the equipment, and lower upgrade and maintenance costs. It's essentially impossible to perform maintenance effectively without a plan. And with that, I'm going to put on the screen a poll question. What's your biggest challenge when it comes to maintenance? Is it that you're unclear on the current standards? That you don't have time to plan effectively? Are you stuck in a calendar-based maintenance system? Does your leadership keep shifting maintenance priorities? Or is there something else? Feel free to share that in the Q&A. Give everybody just a minute or so to select an answer, and then we'll continue. Okay, so now we're gonna take a look. You should be able to see on your screen the answers. I'm stuck in a calendar-based system is by far the biggest, the most popular answer. Looks like followed by being unclear on the current standards and leadership keeps shifting maintenance priorities. So all good information. Thank you for participating in that. So now we're going to talk a little bit about condition-based maintenance in NFPA 70B. So why does NFPA 70B compliance matter? Well, in 2024, NFPA 70B took on the status of an NFPA standard as opposed to a guide. And it can be used by OSHA in citations. While it isn't adopted by governmental jurisdictions the way the National Electrical Code is, it is the consensus standard for maintenance in the United States. By following it, downtime, exposure to hazards, costly repairs due to delayed maintenance, and suboptimal equipment efficiency can be avoided. So when we talk about condition-based maintenance from an NFPA 70B perspective, we're really talking mainly about NFPA 70B Chapter 9, which covers maintenance intervals, criticality, and condition assessments. So, what is condition-based maintenance? Simply put, this is the use of the condition of an asset to determine when the next maintenance is required, rather than solely focusing on a specific and unchanging maintenance interval. So some things from NFPA 70B. Section 9.1.1.1 permits continuous monitoring or predictive techniques to be used as a consideration when planning maintenance intervals. 9.1.1.2 requires continuous monitoring or predictive techniques to be based upon manufacturers' recommendations or accepted industry practices. And Section 9.2.1 requires that the manufacturer's recommendations be followed for each of the maintenance scopes described in the standard. So a key takeaway here is that it's really best to have a manufacturer's recommendation for when maintenance should be performed and what maintenance should be performed. However, if all you're relying on is the manufacturer's published O&M literature, you're likely to be locked into a fixed calendar-based maintenance cycle. And we'll talk about that in a minute. So what happens if you don't have manufacturer recommendations? In that case, in FPA 70B, Table 9.2.2 gives maintenance intervals for different types of electrical assets. These are based upon the physical condition of the asset. They're numbered as condition 1 to condition 3 or non-serviceable. The lower the condition number, the better shape the asset is in, and the longer Table 9.2.2 will allow between maintenance intervals. Condition 1 is where the equipment appears to be in like new condition, and the enclosure is clean, free from moisture intrusion, tight, has no unaddressed notification from the continuous monitoring system or active notifications from predictive techniques, and previous maintenance has been performed in accordance with the facility's electrical maintenance program. This is a high bar. This is like new equipment. Condition 2 is similar, but with some issues. Deviation of maintenance results, possibly from past results, or previous maintenance has revealed issues requiring the repair or replacement of major components of the equipment, or there have been notifications from the continuous monitoring system since the last time the equipment was assessed. Moving down to condition 3, it indicates more serious issues. So condition 3, the equipment has missed the last 2 consecutive maintenance cycles, or the last 2 maintenance cycles have revealed issues requiring the repair or replacement of major equipment components, or there is an active or unaddressed notification from the continuous monitoring system, or there are urgent actions identified from predictive techniques. And finally, non-serviceable indicates that the asset poses an imminent risk of injury or negative health effects to personnel and should not be accessible to unqualified persons. So, I'll pose something to you. Wouldn't it be nice if equipment manufacturers would give a way to assess the condition of their equipment and recommend when maintenance should be performed? Let's save that question for a little bit later in the session, but for now, let's talk about what a continuous monitoring system is, and what it should have to facilitate condition-based maintenance. So what should be monitored in a continuous monitoring system for a condition-based maintenance approach? And the answer is, it depends. It depends upon the type of asset being monitored and how it's being used. One common theme, though, is that modern equipment has the ability to communicate its condition if the right options are in place. So the following are a good starting point for electrical distribution equipment like switchboards and switchgear. And I'll start with the most basic, the most fundamental component of any equipment continuous monitoring system is continuous thermal monitoring. A close second is current and voltage monitoring for at least the main overcurrent protective device. Even better is power quality monitoring. For medium voltage switchgear, the Cadillac is partial discharge monitoring. For liquid field transformers, the top of the option list is online dissolved gas analysis, or DGA. And we're going to talk a little bit about each of these. So let's start with continuous thermal monitoring. For electrical distribution equipment, thermal monitoring is the single most fundamental and impactful continuous monitoring system that can be added. And the reason is because heat is the enemy of insulation materials. And by monitoring the temperature of cable terminations, busing, and the equipment internal and external temperatures, the presence of detrimental sources of heat, such as suboptimal electrical connections, can be detected. This is really where the rubber hits the road. It's been shown that 25% of events leading to electrical failure or fires are due to loose or faulty connections, and 20% are due to environmental conditions such as ambient temperature and humidity. All of these will show up if appropriate continuous thermal monitoring is applied. There are multiple options for the technology used, much more time than I have here today to talk about them in detail. Examples are thermocouples, thermistors, RTDs, IR sensors, phosphor photometry, and surface acoustic wave. A best practice for sensor technologies which require a source of power is to use sensors which are able to harvest energy from the current flowing through the location being monitored. Where humidity monitoring is an option, it's best to have this also. So, having exact temperature and humidity information on a continuous basis is empowering, but care has to be used in the setting of alarm set points so that they're realistic and they reflect potential encroachment upon equipment and cable temperature limits. And those limits are going to be different for different types of equipment and cabling. Second, basic current and voltage monitoring for at least the main overcurrent protective device is a necessity for switchboards and switchgear. And because the heating effect over time is what's critical, again, heat is the enemy of insulation, both instantaneous and demand reading capabilities are required. So this can be a separate device, like we've shown on the slide here, or in some cases can be built into things like low voltage circuit breaker trip units or protective relays for medium voltage equipment. In order for this to be most efficient, logging and communication capabilities are definitely recommended. Otherwise, you would end up sending someone to the equipment periodically to take spot readings, and this is of limited value. That's really not continuous monitoring in the definition that we're using here. Alarm thresholds for this type of metering should be set based upon the current carrying capabilities of the equipment. Unlike thermal monitoring, the basic current and voltage monitoring shows loading issues that are one type of causative factor for equipment insulation overheating. Expanding monitoring to include power quality monitoring is a step up, and it allows for the addition of harmonics, sag swell, surge, wave shape, and other data to give a more complete picture of the power environment that the equipment is being exposed to. Logging and communication capabilities are even more essential than for the basic and basic current and voltage monitoring, just due to the sheer amount of data available and the optimal time frame for reacting to power quality events to avoid long-term damage to the equipment. For medium voltage switchgear, partial discharge monitoring allows for identification of insulation defects which may develop over time. Unlike factory partial discharge testing, this is not a single test, but a continuous monitoring for partial discharges. So what are partial discharges? Well, partial discharges are so called due to the fact that they consist of arcing discharges and voids in switchgear insulation. But these arcs don't go through the entire thickness of the insulation. If they can be caught early before they develop into full insulation failure, then costly equipment downtime can be avoided. Partial discharge monitoring typically operates through electromagnetic or acoustic sensing. The results require interpretation, though, much like a radiologist interprets an X-ray. Without interpretation, the data wouldn't mean much. At the top of the options list for monitoring of liquid field transformers is online dissolved gas analysis, or DGA. Traditionally, dissolved gas analysis was done by periodically sampling transformer fluid and sending it to a laboratory for analysis and interpretation. Over the years, continuous but expensive online DGA options came into the market, but these were generally limited to large and critical transformers due to the cost. In recent years, the value of a partial online DGA has become recognized. With partial online DGA, only a few or even one key dissolved gases are detected, which lowers the cost versus the traditional online DGA setup. However, the presence of the gases monitored indicates a potential issue and can trigger further investigation via oil sampling and lab analysis. Like partial discharge monitoring, DGA results require interpretation, and this is most efficient if this is automated with specific recommendations for remediation actions. Okay, so now everything we've talked about so far, all these different types of sensors, and we've scratched the surface here, right? Trying to give some of the most basic and impactful types of monitoring that can be put into equipment. But everything we've talked about so far is going to result in a large amount of data that's generated. It's continuous monitoring. The data has to go somewhere. Even for just one piece of equipment, you're going to get a large amount of data. And there has to be a way to put that data into perspective. And that's the challenge that we're going to talk about next. I'm going to turn it back over to India, who's going to talk about a way that this can be done. India?
Thanks, Bill. All right. So, you're absolutely right. We've seen from Bill now how continuous monitoring, whether it's thermal, current, voltage, your power quality, or dissolved gas analysis, can provide the insights needed to move away from that reactive maintenance towards a smarter predictive approach. But as Bill mentioned, all that data can be overwhelming. And that's where connected services comes into play. We're not just collecting data, but we're also helping you interpret it, act on it, and drive meaningful outcomes. So now let's talk about how to go beyond compliance, how to go beyond your time-based, calendar-based maintenance with EcoCare. This is Schneider Electric's connected maintenance program that turns insight into action. But before we do so, I'd love to take a quick poll to learn better how confident you all are in your current systems to prevent critical power failures. So A, very confident. B, we're somewhat confident there. C, not very confident. Or D, not confident at all. Let us know, how confident are you in your current system's ability to prevent critical power failures? All right, let's go ahead and see how you did. All right, majority of you all are somewhat confident, which is great. What I'd like to do now is showcase where you can increase that confidence level to very confident. And those who aren't quite there, hopefully you can have some takeaways that you can start applying today, as early as today. So just going through, before I get into EcoCare, I'd like to showcase how Schneider Electric is applying connected maintenance to help move beyond compliance, right? And I'd like to talk about one of the most critical outcomes of that shift, and that's reducing the probability of electrical fire events, right? So for facility teams, fire risk isn't just a safety concern, as you know, it's a business continuity issue. Downtime, damage, and liability can all stem from electrical faults that go undetected until it's too late. And that's where Schneider Electric's Electrical Fire Index comes in. This is a powerful example of how we can take all of the analytics generated from continuous monitoring and turn them into actionable insights, and that's specifically focused on fire prevention. So our Electrical Fire Index combines real-time monitoring data with advanced analytics to assess the risk level of electrical fire across your assets. So it doesn't just alert you, it localizes the risk, it prioritizes it, and it helps your team take immediate action before the fault becomes a fire. So for you as a professional, that means that you now have proactive risk management, a smarter resource allocation, and a greater peace of mind knowing that your systems are protected. So let's take a closer look at how this works and how it fits into the broader strategy for a safer and smarter facility. And that's here, looking at how we're reinforcing electrical uptime. This is a critical outcome of connected maintenance, right? And so for your teams, uptime, again, isn't just a metric, it's a mandate. So whether you're managing a hospital, a data center, a manufacturing plant, or even a school district, unplanned downtime can mean loss of revenue, your safety risk, or service disruption, right? And this is where we now apply Asset Health Index. And you've seen this image on a few slides before, but let's make this into practicality. So I want you to imagine you're able to see the health of your electrical infrastructure, not just at the system level, but down to the individual components. So with 24/7 continuous monitoring, based on all of the insights Bill mentioned earlier, the Asset Health Index gives you a clear view of aging and wear at the component level. It also provides a site-wide health score to guide maintenance planning, and you get real-time alerts. So this is easy access to data through our secure web portal. So let's say you're overseeing a facility with aging switchgear, right? Instead of waiting for failure or relying on a calendar to do maintenance, you can use the Asset Health Index to prioritize maintenance based on actual condition and criticality. So that means smarter budgeting, fewer surprises, and better uptime. And this is the kind of insights that turns maintenance from a cost center into a strategic advantage, right? So moving along here, we've talked again about the health index now, which helps you monitor those individual component and overall site health. But what happens if when you're responsible for an entire fleet of aging infrastructure, right? Perhaps you have oil-filled transformers spread across multiple facilities. This is where enhanced visibility becomes essential. So for your teams, transformers are often out of sight, right? And they're out of mind until something goes wrong. But with our fleet level monitoring, you can now identify and classify potential issues across your entire transformer fleet. And this will help you focus resources where they're needed the most. So we're using AI-powered models, which will be automatically upgraded as part of EcoCare, right? This is a solution that complements industry standards. And what we're doing is providing a uniform fleet assessment. We're also getting the transformer fault qualification, and we're prioritizing that maintenance planning based on the insights we're learning from this assessment. So, say you're managing a university campus or a multi-site healthcare system, instead of manually inspecting each transformer or reacting to failures, you can now use this tool to pinpoint which assets are at risk, which ones are aging fastest, which one is healthy, and where to act first. So this is, again, turning your visibility into strategy, and we're making sure that most of your critical assets gets the attention they need before they become a liability. And then, finally here, we've looked again at all of our analytics and how they're reducing fire risk, we're reinforcing uptime, we're giving visibility across transformer fleets. But now I want to talk about the bigger shift here. And that's what makes all this possible, right? So this is from moving from your time-based maintenance to a condition-based maintenance approach. So for your sites, right, maintenance may still run on a fixed schedule, whether the equipment needs it or not, right? But as we've seen, this approach can lead to risks. You can waste resources or even have unexpected downtimes or even modernize gear that's not yet needed to be modernized, right? So condition-based maintenance, we're flipping that model. We're using real-time data to determine when maintenance is actually needed. So this is based on your health, the performance, the risk profile of each asset, right? And the benefits are super clear, right? We're reducing costs, fewer disruptions, safer site, smarter prioritization on-site activities, and of course, we're extending that lifespan. And so this is where it really hits home, right? We've learned 91% of respondents in a McKinsey study said that their top goal for predictive maintenance was reducing repair time and unplanned time, right? And that's exactly what condition-based strategies are designed to do. So, here we're taking it a step further with the maintenance index. If I advance to the next slide here. So by analyzing the asset condition, we're using the patterns, the trends, the thresholds of your site, and we're understanding the environment, and also our recommendations from Schneider Electric. And what the maintenance index helps you do is optimize, again, when to schedule that maintenance activity. So let's make this real, right? On this slide here, you're seeing a site that has a health score of 1, 4, or 5. So, you're a facility, you have a mix of aging or newer equipment. And so instead of treating all of your assets the same, this maintenance index gives you a super clear view. If the index is low, like the example 1 out of 5, there is no action needed. Your equipment is in good shape, and there is a potential to extend the maintenance activity out to 5 years, keeping us in code and compliance with NFPA 70B, right? Now, we identify that you have a health score of medium. That's time for us to all reassess, right? Our experts can help you reschedule maintenance to avoid unnecessary disruption and also pinpoint exactly what's requiring a maintenance intervention. And then finally, if it's high, we have immediate action that needs to take place, right? And this is going to require, to prevent failure, right, a downtime. So this is how you get maintenance right, where you're aligning your strategy with actual condition of your assets, not just the calendar. So whether you're managing a single site or a complex portfolio, this shift isn't just about technology. It's about transforming how your team works, plans, and protects your operations as well. So transitioning into EcoCare, I want to bring it all together. Everything you discussed, from buyer risk reduction to asset health visibility to dynamic maintenance scheduling, it all leads to one powerful outcome, and that's an optimized operations performance. So for you all, this isn't just about technology, it's about solving real problems, right? How do I reduce unplanned downtime and disrupt operations and cost thousands? Or how do I stretch limited resources across an aging infrastructure? Or how do I meet sustainability goals while keeping systems reliable? So with Schneider Electric's connected services, including EcoCare, you're not just reacting to issues, you're preventing them, and you're making data-driven decisions that can cut your unplanned downtime up to 75%. You're reducing your on-site maintenance costs up to 40%. And of course, naturally, you're extending the life of your equipment, which is avoiding premature replacements. And this can contribute directly to your CO2 reduction. So this is what a modern facility management looks like. You have smarter, safer, and a more sustainable site. So whether, again, you're managing a hospital, it could be a university, it could be a government building, but all these outcomes can translate into real operational wins, less disruption, more control, better alignment with your strategic goals, right? So let's talk about what this actually looks like to take the next step for a few minutes, and then we'll open up the Q&A. So I want to finally introduce you to EcoCare, right? This EcoCare is Schneider Electric's connected service plan, and it's designed to help you move from a reactive maintenance to proactive life cycle support, while staying ahead of evolving compliance requirements. So what we're delivering here are 24/7 monitoring by those who designed your system, manufactured your equipment, and we can flag issues before they become problems. EcoCare also provides condition-based maintenance solutions, again, which aligns with NFPA 70B. This helps you prioritize service based on the actual health of your equipment health, not just the calendar or time frame that tells you to do maintenance. We also have exclusive access, so you can reach our experts immediately. You skip the queue. There's training provided. You have member benefits. You have spare parts, and even have extended warranty if needed, right? And finally, you have a dedicated customer success manager. So they act as an extension of your team, helping you navigate maintenance planning, performance tracking, and long-term strategy. So whether you're, again, managing any types of sites, EcoCare will help you simplify your maintenance planning, reduce that unplanned downtime, extend your equipment's life cycle, empower your team, and of course, meet your compliance with confidence. So this isn't just a service plan, it's a strategic partnership built around your facility's success. So now I want to take just a few final minutes to showcase what it would be like to experience EcoCare for your site. So we understand, right, knowing the status of your critical power assets at all times is a non-negotiable. EcoCare gives you a centralized real-time dashboard that consolidates asset health insights, again, your maintenance history, your service contract status, and then any open actions, or it also flags any risks that you may have. So when your leadership asks for a status update or an auditor walks in, you're ready with answers. And when support is needed, you're not routed through a generic help desk. You get access to our technical experts immediately with 24/7 emergency response and accelerated on-site support. Because delays cost money and compromise continuity, and with EcoCare, goes against our goal here, right? You're also backed by a dedicated customer success manager, as I mentioned, who helps build a roadmap aligned to your facility's performance, compliance, and resiliency goals. Now, when it comes to monitoring and optimizing your site, you're shifting here your strategy from reactive to predictive. So through our Connected Services Hub, your assets are monitored continuously by engineers who understand your systems and the environments they support. So, we tailor our performance, in the thresholds to your facility's unique conditions. We're considering heat load, your location, and your usage patterns. And when something drifts out of spec, like insulation degradation or an abnormal current draw, you're alerted instantly. And through our platform, you get expert analysis and clear next steps, so you can act before issues impact safety, compliance, or even uptime. Now, when it comes to maintenance, right, we're going beyond maintenance here. Under EcoCare isn't just scheduled, it's strategic, as I mentioned. So we're delivering this by the engineers who built your equipment. So that means faster assessments, you get more accurate diagnosis, and of course, smarter interventions. And with condition-based maintenance, again, we are using real operational data and your maintenance health index to determine when exactly and where to act. So reducing your labor costs and minimizing disruptions. And then our premium tier within EcoCare, all this is included, right? So we can include on-site interventions when needed, so you have no surprise invoices with the solution. And then when it comes to investing in your infrastructure, you're not just buying equipment, you're investing in years of performance and reliability and peace of mind, right? So that's why EcoCare's extended warranty goes beyond the typical coverage. We're offering up to 5 years of protection here. We're including labor and repair parts at no additional cost. And so this isn't, again, just about extending time, it's about eliminating uncertainty. So once an unplanned repair in year 4, that could easily offset the cost of warranty several times over. And when in that moment comes, you're not just waiting in line. EcoCare customers get premium support to our customer care center. So you're skipping the queue, you're connecting directly to the experts, right, who know your systems best. And what makes this different is that you're not relying on a third-party service or provider or generic support teams. You're backed by, again, those who built and installed your equipment. So finally, just to paint the picture of EcoCare, we also are investing in your people, from live workshops to on-demand webinars. We're offering tailored training to help your staff. You're going to be able to perform smarter and with safer equipment checks. You can respond confidently to any alarms that we provide or faults. And then, of course, you can understand the systems better that you're managing, not just operate them. So this is an exclusive with preferred and priority access. And so in a field where we all understand skilled labor is scarce, the turnover is real, and investing in your workforce means that you have fewer preventable incidents, faster recovery from issues, and a stronger ownership of performance and safety. And that's how you build a culture of resilience, right? Not just in your equipment, but across your entire facilities organization. So, just to sum it up, EcoCare gives facility professionals the tools, support, and strategy to move from a reactive maintenance to a proactive performance, aligned with code, built around your team, and optimized for operational excellence. So whether you manage a single site or a multi-campus portfolio, condition-based maintenance is one of the most powerful upgrades you can make to reduce risk, extend your asset life, and of course, improve reliability. All right, so that concludes our segment. I really thank you for your time. And at this point, I think we're gonna open up to the Q&A.
Great, excuse me. Thank you so much, India and Bill, for the great information. Yes, we have some time for Q&A, so if you have a question, please submit it into the box below. We have one from an attendee. Bill might have answered it to him directly, but I think others might have the same question. What factors contribute to the calculation of the maintenance index?
And I haven't released this to anybody yet, but I'll go ahead and say it here, and then I'll go ahead and send to everybody. So it really depends upon the equipment that's installed and the monitoring options that are installed in that equipment. And so these include, but they're not limited to, load capacity for the equipment, operating temperatures from continuous thermal monitoring, humidity levels, mechanical wear indicators, and then the data on when the last maintenance was done and what the results of that are.
Great. Another question here. Does the condition-based maintenance plan, is it fully acceptable and compliant to the OEM warranty and insurance companies' claim clauses? He's asking, without going through extended warranty and additional justification documentations when it comes to equipment failures and insurance claims.
So I'm going to let India answer that one.
Yeah, so is it fully acceptable and compliant to the OEM warranty and insurance companies' claim clauses? I would love to follow up on this piece. I'm not quite sure in the OEM warranty clause at this moment, but I'd be happy to follow up with you all very quickly on this.
Great.
Yeah.
So if I have a preventative maintenance schedule in place, how would EcoCare fit in with that without disrupting my operations?
Okay, yeah, I'll take that one. So how would EcoCare fit in without disrupting? Yeah, so EcoCare, again, isn't about throwing out what's working. It's more about enriching what you already have in place, right? So your current preventive maintenance plan is the baseline. EcoCare layers in our digital monitoring solution. So that means that you can keep your existing schedules while adding a smarter decision point based on actual equipment health. So over time, you may even be able to adjust or extend the certain intervals that you have without saving time or costs or increasing that risk, right? So the integration is seamless, right? Where no major operational overhauls are required. What would happen, right, is we would ensure that you have the right connectivity built in during your existing maintenance cycle. And then from there, we'll be able to have even more data points to ensure that we're not messing up or disrupting your operations flow today.
Excuse me. Thanks for that. Why would you say lifecycle support is more important for facilities now compared to even, a few years ago?
Yeah, I'll take it, Bill, and maybe if I miss anything, let me know. But, I would say about 5 years ago, most facility teams could operate with planned preventive maintenance and it still meets the uptime targets. But today, it's a different reality. Our equipment is more connected. You're seeing our regulations are becoming more rigorous and our skilled labor is hard to find, right? So the cost of unplanned downtime is significantly higher. So we also have, also far more data coming from our assets than ever before. So lifecycle support does help our teams take advantage of the data. You're able to extend, again, the equipment's health and life and improve the compliance and reduce that risk of costly failure. So in short, it's no longer about fixing what's broken. It's about, being proactive and protecting your investment across the full life cycle.
And just to add to that, right, time marches on, right? So from a standpoint of the kind of pressures and challenges, financial, business, and other that facilities face, the more help the better. And I think the life cycle support certainly can be a key piece of that. The other thing that I'll just mention is the fact that to really take advantage of a lot of the advanced features built into today's equipment. For example, I talked about mechanical wear indicators earlier. That is best done with life cycle support. It also lets you take advantage of things that might be an upgrade in the future that might even give additional information. So that can make life cycle support quite attractive.
Okay. Yeah, everyone, take advantage of this time with Bill in India. Use the Ask Questions module at the bottom of your screen to ask anything that you want more information of while you have the time with them today. How quickly would you think facilities can start seeing measurable results from a life cycle support program?
Mm-hmm. Yeah, I'd say, the timeline definitely depends on your asset mix, right? How, and the data maturities, how aged is your equipment? How new is it? And so, a lot of our facilities are seeing early wins, like reduced emergency call-outs, a more accurate maintenance planning within the first months, right? Now, as the system gathers performance history, the predictive insights get sharper, typically showing measurable reductions, honestly, within the first 6 to 12 months. So the beauty of this is that we're compounding value. So the longer it runs, the more optimized your operations can be. So, but again, we're seeing pretty quick, results, right, from early integration of the solutions that we provide.
Sure. And you might have covered this a bit in the presentation, but can you explain again how would EcoCare get you from that reactive maintenance to more of a predictive preventative all the way to this condition-based maintenance where ideally facilities will get to? Excuse me.
Absolutely, yeah. So it's all of the features and the connectivity that Bill mentioned earlier, right? We're connecting those assets using sensors, your breaker health index. We're putting in probes into our transformers, and we're able to assess again, those customer connected points, how well connected they were, right? So we're connecting our assets, right? And we're leveraging our engineers to understand the real-time performance to spot those early signs of deterioration or an issue or determining when we need to go and be dispatched to support our customers. So, what EcoCare does again is connecting your site. It already has a lot of analytics that it provides, and we're able to determine exactly how healthy your equipment is. And that shifts us from a fix after fail to address before fail, right? And so that, again, reduces the downtime that you may be seeing today.
And look, condition-based maintenance is impossible without knowing the condition of the equipment. That sounds kind of like a stupid thing to say, but you have to know the condition of the equipment. And in order to get that, right, I mean, we talked about, kind of the old school way of getting the condition of equipment. I went through the different conditions in NFPA 70B. At the end of the day, having that data, having that connected data, and letting the equipment talk to you, as long as you manage that data correctly, that is what gets you on the road to condition-based maintenance. And yeah.
Yeah, kind of, building on that, you're talking about collecting data. Where would you, your recommendations to install these, continuous monitors to collect this data?
So we talked a little bit about that during the presentation in the context of switchboards and switchgear. And certainly from a power distribution standpoint, those are some pretty critical places. However, what you're going to find is that moving forward, there are the equipment that can accept these types of sensors and monitors is going farther and farther down into the system. And so what I would say is that everywhere you've got a device that's an intelligent device, it's worth looking into it in terms of what data can that device give you. For example, the individual drive for a motor, right? And it's surprising how much data that device can give you, but you have to be connected to it, and you have to be able to interpret the data.
Another question here from an attendee. What is the difference between infrared testing and maintenance testing versus condition-based maintenance?
So if infrared scanning, okay, will give you a snapshot of the condition of the equipment at the time that you do the infrared scanning. Now, typically, even though some equipment has windows, in the majority of cases, you're going to have to open up equipment, right? And you expose yourself when you do that. So that's one thing that's different. That you're getting a snapshot, and a lot of times you're going to have to expose yourself to hazards because the equipment needs to be running when you do the infrared scanning. It needs to be under load. And so those snapshots can certainly be valuable. But imagine having that sort of a snapshot, but instead you've got it in real time, so you can see when the uptick in temperature at a particular place happens. That's powerful. And that's where continuous thermal monitoring really comes into its own. Little shameless plug here. There is enough interest in continuous thermal monitoring that there's actually an IEEE guide that's coming out on that soon. It's going to be IEEE 2969 guide for continuous thermal monitoring in distribution equipment. I think it's in motor control centers up to 52 kV, if I recall correctly in the title. So a lot of interest in continuous thermal monitoring, but it is distinctly different from taking the snapshot that is an infrared scan.
Okay. We were talking before about kind of adding these monitors to equipment to capture the data. Can they be added to older systems as well?
Yes. I mean, it depends on the equipment and vintage we're talking about, but the stuff that I talked about in the presentation, the different kind of the basic five or six types of sensors and where they can go. They can typically be retrofitted. The thing that is the thing that may not be retrofittable, it depends, is, you know, some custom things like we talked about breaker wear indicators, for example, right? You'd have to retrofit a newer circuit breaker into older equipment to get the advantage of something like that. But the basic stuff that I showed, yes, it can go into older equipment. Yes, it can.
Okay. Well, great. Thanks so much. India or Bill, any final thoughts you want to leave our attendees with today?
Hey, we appreciate your time today. We appreciate taking a few minutes to spend with us. We know your time is valuable, and so thank you.
Yeah, and I believe we're going to get a download here after this call concludes on our eight steps towards NFPA 7AB. You're also going to learn more about EcoCare in our statement of work, and also access to our website. And then here's another plug. We are hosting our Innovation Summit this next month, actually. We'll be highlighting all of our solutions in a demo style format in Vegas, and we definitely invite you all. So, secure your spot today. It's going to be a great time showcasing what Schneider Electric can do for your business. But again, thank you all for your time.
Great. Thanks so much, India and Bill, for the great information today. Thanks everyone for attending our event. Just one last reminder, this event was recorded and will be archived on facilitiesnet.com. If you want to revisit any of the information, or if you think you have any colleagues or employees that want to watch, look for that in about a day or so. And once again, we appreciate everyone being here, and this is going to conclude our event today. Have a great rest of your day. Thank you.